Ok, dovremmo essere live ora. Sono live, sì. Grandi. Ok. Hello everybody. My first live stream. We start with the challenge 3, list sort using try. I'm using educative. Here you find a bunch of problems and like I'm starting this problem. Let's see. It should be about tries. So we will implement the data structure, I think. List sort using try. In this problem you have to implement the sort list function will sort the elements of a list of string. So I think the idea is to get this list and print out something like this, so an ordered list, but I think that the main goal here is to use a try, so we need to implement a try type of that data structure and write a function which will use the try to sort. So first we will add the words and later we will sort them. So pretty clear, no? So let's go my studio code. I will use Python. So I was doing some challenges before, but I mean, doesn't matter. So let's go to Python challenges. I move this out. Okay. So Control S. Try. Array to try. Let's call it. Try. Okay. Dot by. So let's start with the main function, and also let's write the test. So let's start. This I suppose is going to be the result. So let's start implementing the main function. This series will be about mostly code challenges I'm doing to prepare code interview or code camp or even competition, in case you wanna see how some problems can be solved. But in general, is a pretty general series that will talk about algorithms and things like this. So here we go implement the main function. Okay, so this is the way in Python to invoke the main function while we execute the script from command line using Python and the name of the file. So these are the keys. This is the result. So I assume that it will work something like this. We will create a file. So we will need to create a class try. In this try, we will insert all the keys we have here. So for key in keys, we will do try key insert key. And at the end, maybe to check if they have been inserted, we could even implement the search, but now it's not what we want. Anyway, at the end we will have a try dot what was the function name, which is try sort list, something like this. Try sort list, which return something which should be as the result we have here. So if we do assert result equal try sort list, this should be always true. Let's So for coherence, use always a double affix. Okay. So okay. So let's go to implement the trie. What is a trie? Trie is a tree type of structure that allows us to store words based on letters, and we can keep the order of the words inside a trie, because each node we will have could have 20 up to 26 children, one for each letter of the alphabet, and in this way we can store any type of word we want. An example of a trie could be like, we have a root node, we could have, so we have the root pointer, which has A, B, C, D, E, blah 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 until Z, no? And each of this node could end there, or instead it could have other children. Could have even other 26 children, something like this. So no, so etc. So, and for each one of these, for each one of the letters we have in the trie, we can have 26 children, one for each letter, and if we follow one path from root to leaf, we will have a word. For example, A, B could be a word, but we have to remember that we have to put a sort of variable that is going to tell us if that given word is finished or not. So in case here we will have a flag, like end word, that could be true or false, no? And if it's true, it means that, for example, we will have stored the word AB. Instead, if it's false, it means that most probably it will continue to another word, or it could even not be there. But anyway, let's go to implement the structure, because I think it's easier, no? If you have familiarity with binary trees, it should be pretty straightforward. So, first of all, we define a class node, where is the unit of our trie. We define the constructor, which is self data, okay. We do self.data equal data. Each node will have other two types of attributes. One is self.children. So this is an array where we will store the pointers to the possible children, and we said we can have up to 26 children, and we initialize it to none. And we have also self.end word, that is what we were discussing before, in order to establish when a given word terminates. So define the class node, we go with the class trie. So here again we will have a constructor which will have a data as well. So we store where we store the letter for that given. No, really, actually, we don't need this. Yeah, we don't need this. But we could put a sort of description, just in case we will have multiple tries. We can describe what we are doing with this one. Description. Okay. We will have also another private function. You can see in Python a private function for a class there isn't a way to declare them, so everything is public, but if you put an underscore before the name of the function, this means it's private. So we do get index. This will help, is a helper method we use to establish where a given character, where a given letter is placed inside the children array. No, so we go def get index star blah blah blah, and what is gonna do? This method is gonna return back. No. I don't remember what is the function to convert Python char to ASCII code. This was ORD is the function. So we will use the ORD char minus ORD A. So what it does, this if I'm not wrong, let's go to take a shell. Let's take this shell. So here, if we do IPython like this, it'll take a while. My PowerShell is pretty slow. Okay, so what it does, the OR function? The OR function in Python gives you the ASCII code of a given character. So the alphabet letter, they start all at 97. So A, for example, B, 98, C, blah blah blah, and it's like this for the next 26. So so if we do 97 plus 26, let me, okay, 123, no? It's 123. So if we do ORD 123, we should get the Z, okay? Sorry, 100. Pardon. If we do no, sorry. Okay. So if we do ORD of Z, we should get back 122, no? So because yeah, we start from 0, okay. So the idea is that if we do ORD Z minus A minus ORD A, which is 96, we should get back a number which is in the range between 0 and 26 for all the letter between A and Z. In this way we can I extract the index, which will be the index where we will place the a given letter in our array, which is 26 places long. So define the get index. So now you understood why I did it. I will implement the insert method of try. What is the insert method? The insert method will of course take a key function, key input. So we will need to store a given key. How do insert things in a try? Well, it's pretty easy to describe. First of all, we need to get the first character, put it in the right place in the array of the children, and take the second character, and so on. So the idea is that we are gonna cycle through all the characters in a given key, and we will add it one by one to the try. In order to do that, first of all, I would check if the key is none, or length of key is equal 0, because in that case we just return. So just to deal with edge cases. Later what we will do is going to be that key dot lower, I think, because the idea is that a given key we will store only lowercase letters. So key is going to be key.lower of itself, and we are gonna use a current node variable to store the current node we are analyzing of a trie. So in the first place is going to be the root, okay, and from this moment on we just cycle through the char in key, through the characters in key, and for this given character we need to get the indexes, and this way we know which given spot, which is the given spot for that specific character. So we'll store it in index. So if current node dot children in position index is equal none, it means that the character is not there. In that specific case, since we are inserting, we need to add a new node. So it means that in this spot, if there is no node, we are going to create a node where we are going to store the current character, which is char. Right? Otherwise, so if this doesn't happen, it means that the char is already there. So we are fine. So we don't need to add it. So what we do next, we just go to the next node. So the current node becomes this. Done. Later, what we are gonna do? Later we are gonna just set that for the current node we are, the end word is equal to, because a new word has been added. So set that. This is the method, the insert method. Let's implement also the search method just to be sure that what we are inserting is there. So it's going to be more or less the same. So I'm going to copy paste it, and I will go through the code again, try to modify what I think should be modified for the search. So the edge case scenario, we leave it. Actually, in the search, the result should be false in case it's not there. So return false in case of non-key or empty key. After that, the idea of the search is always the same. We go through all the node, but through all the try to see if the character we are looking for are there. Well, the idea is that a character is not there if it's none. So if it's none, we just return false. No. Otherwise, no need to update. We just update the current node, and in case we end a given key, we just return if the current node and word is true or not. Because if it's false, it means that the searcher returned false because that given word is not stored, because the end word should be stored to true if we have a given word, because this helps us to deal with the case in which we are looking for a word, but we have just a word where in the try which contains a substring of that. For example, we have hello, no, and we are searching for L, and L is there, but for the node L, for the second L, we will not have the current node and word flag set to true, because we added just hello, and we had only hello. So this should work. So this is the search. So let's go if what we wrote makes sense. So we insert all the keys and we search for them as well, and we print out the result. The idea is that we should get all true. No? Okay. So let's go here. Python array blah blah blah. Python challenges. Hence. Okay, Python array error, a description maybe, of course, we didn't put, okay, we just put that there was an error in the construction of this. Let's see. Okay. Fine. Should work this. Description. Init missing Oracle positional argument. No, shouldn't. Description. Let me. It shouldn't give me this problem. I think I'm sorry guys, I was modifying the wrong file. Let's do like this, Control Shift S, instead of we go here and we go here and we go save. Yes. Okay, now makes sense. Okay. As no root. Sorry, guys. Description and self.root equal. Let's see. And data we can put the optional. Okay, and now it says that sort list is not there. So this makes sense. Why? Because we didn't implement it. So now let's go to implement this. Sort list of this given try. So what we are gonna do in the sort list? Actually, what we are gonna do do a depth first search, because the idea is this: that now that we have all the lists, all the words stored in our try, what we need to do, we just need to return all the words we have inside the try in a ordered, but this in our structure can be defined as do a depth first search on all the possible nodes in our try. How to do that? Well, depth first search is an algorithm to explore graph, and is a recursive one. Instead, breadth first search is more a iterative one, which uses a queue. So the idea here is that we just define a base case, which is the current character. If the current character has the end word flag enabled, it means that we need to add that given word to our result. Otherwise, if that's not the case, we don't add that that specific path to our results, and we keep going with the other letters. And we are going to invoke the same function on all the children of that specific node. For each one of these, we will get some results. We will store them in the results of our functions, and we will, as last thing, we will return the results, all the results from all the children of that given node. So that's going to implement it. First of all, we are gonna do something like this. This is my way to define a recursive function inside a wrapper, because I think it's the cleanest way in Python. So we will need the root, we will need the length, not the length, we will need the results, should be an empty list when we start, and also the path. So which are the words, which are the letters until now, and we do semicolon. And here we just return underscore sort list of root self.root path equal empty path and results equal empty list. And here we just return results, okay? And we will see why. Results. Okay, we miss a comma. Okay, so first of all, we go with the standard if to check edge cases, which is root equal none. In that case, we just go and we return results. In case that didn't happen, we just do the check root dot end word. So if root dot end word flag is enabled to true, we just return. We just add to first of all we add to the current path the current character, no? Done. And if root dot end word, we go results dot append path, and that's it. And we could just return the results, but of course we have to invoke this function on all the children. So we go for child in root.children. We do that sort list of child comma path comma results, and whatever returns it goes in results, because in case new results have been added, they will be stored here. In this way, this for starts from the first kid, which is the A, and go to the last, which is the Z. In this way, we are gonna follow an alphabetical order, so we will reach what we needed. So let's save it and let's run it, and let's see what happened. Let's do something like this first. Just print this, so just to be sure that actually it works properly. Okay, it seems that it worked. So as you can see, this is the array, and the assert didn't create any error. So let's try to change it. Let's do the array like this. This now should throw an error. Yes, assertion error indeed. So yeah, it works. So that was how to deal with tries. Tries seems to be pretty popular in the interviews, mainly at Google. But let's see. So let's move on to another small. So here, guys, I don't want to advertise Educative, but it's a pretty good challenge. It's a pretty good site. There are a lot of challenges. I use it as a exercise book, let's say, because in case I don't know something, I can go and check the solution. Some solutions are not very good, but of course they work. So at least you have a reference, let's say. So solution review list. This I don't review it usually because I think we made it. We made it. So that's good. Let's go to challenge 4. Word formation from a dictionary using a try. So first time I see this problem, so I'm doing it live with you. Let's see. Let's go and read it together. You have to implement the is formation possible function, which will find whether a given word can be formed by combining two words from a dictionary. We assume that all words are in lowercase. Input: a dictionary and a query were containing lowercase characters. So let's return true if the given word can be generated by coming to. Okay, so if we have the hello, it means that the hello, we have word. Okay, the word is hello word. Interesting. So the idea is that we go through. We have a try and we have a word. So we start to look for that given word. Is there does it exist, this word hello, for example? No. So a word should be there. Hello. Yeah. We found hello because the search will help us find the hello. But later we need to find also the word. The word. So as soon as a given word finishes, we restart from the try, from the root of the try, and check if the second word exists. It's pretty strict, no? The specification here. It says by combining two words from a dictionary. So it shouldn't work with 3. It shouldn't work with 4. It shouldn't work with 1. So 2. I think I'm gonna implement it in the data structure we just brought together. So let's go here. Let's create the test case. So until here, we know everything works. Nice. So we go with this dictionary word. Nice. So we create a new try. Let's do it in this way. Let's go with the second. So try 1 for key in dictionary, insert blah blah blah. So we wanna search. Well, we don't need to do it because we know it's working, and we just want the find word. Let's go find word 2. No, 2. And we pass the word. Okay. So this should print true. But for example, if we try to do something like this, something like hello word, this should return false. Okay, pretty easy. Okay, nice. So let's go and implement this method. So let's implement it here after sort list. Find two words. Well, it's gonna work. Hola. Sì. Ah, sì, sì, mi